All right, we're going to continue learning about volume, doing a little bit of review and then getting some background on it. This is session 2 for lesson 1. For this warm up, if you were here, I would have given you 12 unit cubes to build a rectangular prism, and we would have figured out what the volume was. Now, the purpose of this was to kind of see if other people's idea of what that rectangular prism looks like is different than yours. Um, for this, I did make some different versions of it, all with 12 cubes. So I made this version, the second one, and the third one. And the point of all that was to kind of show that like you can have different shapes but have the same volume. All of these have 12 cubes in them to build it. So you have all of that just to see that volume can come in different shapes and sizes, but however much you can put in there, since volume measures how much goes inside of something, is the point for that. All right, so for your notes today, open up to page 9 and we'll get started. So the rectangular prism here is made of unit cubes with no gaps or overlaps. Now it's important to remember that when you're doing volume and measuring it, you can't have any empty space because then that's not going to count towards the volume. So all of these are packed close together. And wants to write an addition equation to find the volume of this prism. So the way we can do that is to view this a couple different ways. So this rectangular prism here, I can turn it into different layers. When I say layer, think of it like cake layers, like a birthday cake. And we got 3 different layers, and each of these layers has 6 cubes in it. So if I know each layer of this rectangular prism has 6 cubes, I can simply do 6 plus 6 plus 6. And we know that is 18 cubic units. However, let me grab a different color here. You can also treat this like a loaf of bread. And you can give it some slices. So I'm going to use red here to slice my rectangular prism. And each slice is worth 9 cubes. And there's 2 slices I can make out of this here, 2 equal slices. So 9 plus 9, that also equals 18 cubic units. So there's a couple different ways to look at it, but we have the same overall volume. Part B, explain what each number in your addition equation represents. So 6 cubes equals a layer. I'm putting these in quotes. And then 9 cubes equals a slice. So you can just think of it in general terms. I like teaching math with terms that we normally use every day. Just makes the math less complicated. All right, let's look below. Number 2 asks, suppose you add another layer of cubes on top of the rectangular prism in problem 1. So the original setup for that was 6 plus 6 plus 6 for the original one. So those were based on all our layers stacked on top of each other. We had 18 cubic units. But if we add one more layer, that's another group of 6. And that will give us 24 cubic units. And that's simple for that. All right. And if I'd done it the other way and added an extra slice, that would have been actually would have given us a different volume, but we'll talk about that later on. All right, turn the page. And this asks, the rectangular prism shown is made of unit cubes with no gaps or overlaps between the cubes. So same deal as the one on the previous page. Now it wants us to write a multiplication equation to find the volume of the rectangular prism. So I'm going to go with layers again. Layers seem to work pretty well for me. And this layer is 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 cubes per layer. And then there's 1, 2, 3 layers. So what we can do here is 8 times 3. That gives us 24 cubic units. Now we could count up all of those cubes and find out that there's 24. Or like some kids were doing yesterday with the IXL assignment, they were using multiplication, so which is a quicker way of doing addition. It's like a supercharged version of addition. So explain what each number in your multiplication equation means. The 8 equals cubes per layer. Cubes, mess that up a little bit. Cubes per layer. And 3 equals how many layers there are. So far, so good. Let's look at 4. How are the addition and multiplication strategies for finding volume alike? How are they different? We'll keep this simple. Let's split that question right in half. You've got alike on one side, different on the other. The alike here is they both methods did the number of cubes per layer. These strategies were different because it's really simple. The operations, and when I say operations, I don't mean like going to the doctor. Operation is adding versus multiplying. That's how they just differed. And we talk operations is adding, subtracting, multiplying, dividing. It's like what I call the big four. So if I ever say that, where I'm talking about what are you doing to do the math in this problem. And the last one, figure A and figure B are built with unit cubes of the same size. Explain how to use the volume of figure A to find the volume of figure B. That's pretty simple. So for A, we've got 1, 2, 3. So figure A equals 3. And I'm just going to put U for units with a 3 instead of writing cubic units. Let's try that. And figure B, since there's 1, 2, 3, 4 columns of them, so figure B equals 3 cubes, 3 cubic units per column. There's 4 columns, and that gives us 12 cubic units, or 12U with a little 3 right up there. All right, and that does it for our notes. Your homework assignment is IXL again. It's DD14. Again, going to 70% will get you a 100% grade. But I don't require kids to go to 100% for IXL because it gets a little frustrating. You can if you'd like, but I'm only requiring you to get that bronze orangish medal to pop up on your screen, and then you know that you're done for the day. All right, if there's any questions, let me know, and I'll be glad to help you out.